Hello people, welcome back to my channel. So today in this video, let's see the nested cross validation, which is a variant of the cross validation approach, and it solves some of the problems which are caused due to the cross validation, that is in normal cross validation. So in normal cross validation, what we had is we had the problem of doing the hyperparameter tuning in one another step using the grid search, and then we had a poor estimation of the error on the training data as well as the test data. So in order to overcome that problem, we have the nested cross validation approach. So let's start. So we know that our data set is divided into two, that is we have this part reserved for training set and this part for test set. Now whenever I draw this kind of representation, so it is a shorthand representation for our data set, that is how we divide training and test set. Now in nested cross validation, we have this part as the outer loop, that is at the very first step when we get the data set, that is when we divide it into training and test set, that becomes our outer loop, and this becomes for error estimation. Next, if we want to do hyperparameter tuning as well in this, what we do is we further split this training set into two parts. That is, we have the training subset and then you have the validation set. Now this part becomes the inner loop and this is used for hyperparameter tuning. So this is how we club both error estimation and hyperparameter tuning in one cross validation method. And so this hyperparameter tuning comes under outer loop. That's why it's a nested cross validation approach. So what you have is basically how it works. So it works in two basic steps. First, you take a part of the training set, that is you have the training subset, only a small amount of training subset is taken. Now this is run on the model and it is evaluated on the validation set. Now in this you choose some parameters, not all parameters, but which caused least error during that run. So this is the very first step. In the second step, what we have is we take these chosen parameters plus now we just take the entire training set as a whole and we run on the test set and its performance is evaluated. Okay, so this is the approach of the nested cross validation. Now what we have is in nested cross validation we have our data set. So whenever it is given to the nested cross validation approach, you have the outer loop at the very outside. So what it does is it basically splits the data set into n number of training and test sets. So you have 1 up till n, here also 1 up till n. Then after that you just estimate the error. So average error on the training data and average error on the test data is recorded, and this entire error on each of the split is given as the generalization error. So this is how the structure and the basic idea of how the nested cross validation is. Now let us understand with the help of an example. So just consider this is a threefold cross validation XV. Now we want to optimize the hyperparameter C for values 1 and 2 of some model, say we have SVM. Okay, so we want to optimize the hyperparameters 1 and 2. Now we need to determine which parameter would be best for this C. So we have our data, say we have 3 data instances P1, P2, P3, and so first we go to the outer loop. So on the outer loop you have the training set, you have the test set, you have this parameter, then you have the accuracy and you calculate the average accuracy. So first of all in the training set you take P1, P2 as training and P3 as test set, Then you have the parameter C as 1, just take arbitrarily, and then you record the accuracy. In the next iteration you have P1, P3 as the training and test set as P2, and then the parameter is taken as 2 and then its accuracy is recorded. And in the final you have P2, P3 combination for training, and in the test set you have P1 and C is taken as 1 and its accuracy is recorded. Now you have the average accuracy, and now this becomes the outer loop. Now here what we said is, in the data set, in the outer loop you have n number of splits, so that split is on each of this record. So here also I just considered only one inner loop, that is for this partition. So for hyperparameter tuning, that is this part mainly is for hyperparameter tuning. So in that you have this training subset, you have this validation set, you have the parameter C, you have accuracy and average accuracy. Now when you consider this part, you have only the training data. So you have in the training subset you have P1, validation set you have P2. For parameter 1, we just swap these parameters. P2 goes into training and P1 goes into validation set. Their accuracies is computed and its average accuracy is recorded. Similarly, you have the same combination with CS2, its accuracy is recorded and average accuracy is seen. So after this, we just estimate which combination yielded the highest accuracy. So that we have, that is 85% with C is equal to 1, and so we have this optimal parameter when run with the model, that is C is equal to 1. So this is how the working of nested cross validation is. So hope you guys enjoyed this. If you found educated from this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.